Okay. Yeah, welcome everybody to another round of Rust. Today Bolivar is going to be talking about enums and pattern matching. So whenever you're ready, take it away.
Sweet. Let me start sharing. All right. So yeah, I agree with Ron's assessment that this may have been good to join with structs. So very similar. So this might be a little bit fast, but it's also very similar to what we talked about last week. All right. So in general, enums allow us a value to be one of several predefined variants. And those variants of that same type could be also of different types. Um, we'll get into that. And there's this other idea that enums allow us to pattern match. So by checking predefined values and patterns, and then execute code based on that. So similar to an if else, but it's so-called if let. We'll get into that. So yeah, we define the enum as a value is one of a possible set of values. So in this example, we have IP address kind, v4 or v6, right? And then we initiate those. We create a variable saying for it's of type IP address kind, variant 4 or variant 6. Um, so yeah, so they can have multiple variants of that same type that whatever that enum sort of type that we have defined. And one of the cool things is that you can use them with structs. So they can basically here we have enum of IP address kind v4 v6, but then we can include that in a struct, right? So when we have struct IP address, we have the kind. So in the field of kind, we can say, hey, it's an enum of IP address kind. And then we can instantiate those the same way that we instantiate structs. So by saying, let this variable home be a struct with this set of values. So very similar to what we saw last week. They can hold, what did I say? Animals can hold data in their variables. Yeah. So they can hold like a type of data, right? If that's going to be a string or an I32 or Boolean types, etc. So we can say, IP address v4, oh, that's going to be a string. V6, that's going to be a string. And then when we instantiate, we declare as in string 127.0.0, etc. So we can also, I think there was an example in the book that just turned this into an I or U32, and then you just plug in the numbers instead of a string value. So the whole, again, variance of the variants can hold different types of data. But then one of the things was that each variant then becomes like a variant function that constructs the instance of the enum. So this is just my little tables to summarize things. So in structs, we have like associated functions that we can implement and or methods that we can implement also. but in enums, I called it quote variant because it was kind of a loose definition in the book. I'm reading the Brown version, so maybe it's not in the other one. But wait, let me see. Oh, I think that example comes. So by holding different complex data, we have enums that can have structs or enums on themselves, and then this is just a little summary of another enum called message that has no data, has I32s, has strings, and has another set of I32 values. And methods in enums, like structs, they can hold methods. So basically by implementing message, calling it to itself, whatever is supposed to happen here. So I guess here we're just calling it and saying it's going to be a method of write a string from hello. And then as it calls itself, should print hello.
Hey, can we just back up a second about this variant business? So Andrew just posted the variants are the names of the different arms of the enum or the different types that can be in the enum. Whereas I think what you were thinking of, that that structs have associated functions and they're often used for to make creation functions. And there are these weird functions that are created automatically with the name of the variant for constructing them, right? But I think you can also have other associated functions within enums as well. You can implement other things for enums that are not necessarily methods in the same way, exactly the same way as you do for a struct. It's just the weird thing is that there's these automatic constructors that are made for enums that aren't created for structs for some reason. I mean, they are sort of, but they have a different kind of syntax that use a curly brackets and to construct one. It does seem weirdly put them next to each other to me anyway. Just like, oh, you make an enum, you use a function call type syntax. When you make a struct, you use the curly bracket syntax in the kind of default way.
Okay, yeah. I think that's what I might have gotten a little bit confused. This whole variant and how the syntax and then the arms. I was like, well, is it just completely different than the associated functions that we see in structs? But okay.
Yeah, that's kind of not the same. It's kind of a different concept, I think. It looks the same. I mean, it looks like an automatically created associated function. But you can also create your own associated function, IP address, colon, something else by doing an implement expression. But
yeah, I think my understanding was like, just that these are, you can call them here like a function in itself, right? Like
it looks the same way you call an associated function. It has the same appearance.
Yeah.
Because of the scope operator there.
Yeah, I think
another thing
gets a little confusing for me because like it looks so similar the way you create a struct and an enum, right? And then the way you like reference an enum, right? Like IP address colon before, like you could also reference functions that way. And I don't know. I feel like there's I guess you have to, if you do it enough, you don't have to think about it, but it seems like a lot of overlap in concepts that use the same or really similar syntax.
I agree.
Yeah.
maybe also worth mentioning that the home object here is of a type that is still IP address. So the value of having an enum here is if you're passing it into a function that can only take something that is an IP address, the only two values that it can take is either the v4 or the v6 with some data in there. And that's something I really miss in R. If you want to pass in something that is strictly of a class, you only get that one class you can do, and it's really hard to pass in something that looks like an enum that can only be of certain values. And technically, the R strings, if you do them as factors, that's what was originally classed as enum, but you can't like get the list of all of them without just evaluating the entire thing. It's very different, but yeah, this is cool.
So yeah, so again, complex data, then the methods. Yeah, like you all say, very similar syntax. Now this is a method, and it's just message, colon, etc. So I can see how this can get overwhelming. Now, there's, I guess, a lot of talk of this like option, that I think comes with the standard library, and it's because Rust doesn't have null, doesn't have the concept, or yeah, it doesn't work with null. The concept of an absent value exists, and it is handled through the enum option, uh, which represents a value that may or may not be present. So this option enum is like, well, none, which would be the equivalent or similar to null, and then some value, right? Depending on the type, right? What are we expecting? But here, this is just to denote that there's a missing or absent value. And the way it works is that we say, well, you're gonna, we're declaring a variable here. Let some number be some 5. Rust, interprets that as an I32, and then some character is going to interpret that as a string. Smart enough to do that for us, but we can also be explicit and say it. And then an absent number be none. So we sort of initiate those variables that way. And did I ring? Yeah. Yeah, so that would be the way that we say, well, this is null, and in every cell or in every case, that's what you're gonna put in. Now, there's also a match control flow, which I think, yeah, the chapter does then kind of incorporate options and matching. So we'll talk about that. So the match, we can check values against patterns, right? And then execute code based on the match. So we can declare this enum of, types of coins. And then through a function, we're going to say, well, we're expecting a UA type, and then you'll match coin being, we can say that, I don't know whether we call it a method or a function, an associated function here, but saying coin, the penny, that's the value is 1, nickel 5, dime 10, etc. So we would be matching that, and then we combine those values inside match arms. So the idea is that we don't want to transfer ownership or borrow ownership through this matching process, because it could. So we bind the values inside match, and that way we can extract the values of the enums, right, and be able to print it out here. So match, basically we pretty much the same, but we have another emu that it's by state or where that coin is from, and we say, well, when you match here, that coin is going to be from Alaska, being quarter, and then the state, so it's going to reference the state is from, because we have this enum here where it also refers to this other enum up here. So none of them match until we reach quarter state. example. I'm going to run this in Rust01 because I don't remember how it worked. So
really like that in the match, like for the quarter example, it feels kind of like an anonymous function, right? Or I don't know. I think that makes sense to me. I guess the other option is like what you might see in other languages, use like a dot to access, something from the enum. But I kind of like this sort of anonymous function kind of syntax.
oh, I guess
You need a main
let
block
me-
around that.
oh yeah, because I'm
Also, this
so-
match is very similar to dplyr's case when.
Yeah. Main. What am I doing? What around all of it, right? Is that what I'm missing?
Yeah, but you're also going to have to call one of the functions.
Forget it. It's
It's
and we-
not set up to actually run. Yeah.
yeah, I should have incorporated that, but yeah, it's actually it's kind of like case when, right? It goes that when it matches, execute this, right? So here we would print out. I think in the example it's a coin from Alaska. What comes out? So yeah, so here's tying it back to this whole concept of option or like handling absent values, where we have use option to basically and match to match either, right? Is it quote unquote null or is it some value? And that's some value, and then you're gonna execute, right? If you match that sum value here, you're then going to execute the sum of I plus 1. So here we perform the operation, right? And say in 5, it does, this is how we said it, but 5 is sum 5. And then the function 5 turns out to be one of these, which then executes, right? So we end up with 6 versus how we've added here, none. It's going to match on that first one, and then just give us none. So yeah, so this is how we would handle matching or trying to match with some null or absent values, and try to or vice versa, and trying to execute code based on that. But one of the things is that matches need to be, they must cover all the possibilities. So you have to consider all of the cases, right? So yes, this is the one that doesn't work. So this code doesn't compile basically because we've just said, hey, match when you find some, but it doesn't have what or the non arm, which would be saying, what happens when it is not, it doesn't match with any of these. So by saying the previous one, right, by saying none equals none, it has this exhaustive and all-encompassing sort of option to handle cases. So that's where catch-all patterns come. So we have a way of just saying, and this is of saying, hey, we're gonna roll the dice, and when you get 3, you're gonna execute this function. When you get 7, you're gonna execute, and then any other. So we just write other. We move player, right? And move player is this function here. And this so that's one way, and then the other way is to say we're going to put an underscore, right? So it catches all the cases that are not these two. Now, the important thing is that the order of operations here matters. So we're basically, the way I see it is like a drip pen, right? Like things are going through, and then all of this is catching everything else after everything has been evaluated to match any of the cases. So we couldn't put this up here, right, at the start, because we would be catching everything. And that wouldn't do what we wanted to. So I think, yeah, like I had said, matching can transfer ownership, so we have to be careful of that, and it, there's ways of doing it carefully. So we have here what we have. Yeah, so we're matching OPT. This sum is catching everything, and then none is none. It prints. Now the thing is that here, exactly. So this one does compile and does work, but then, for example, this one up down here doesn't compile, because we've basically, by saying some s or some value, we've transferred ownership. In the catch-all scenario, it does not. But here we've, so the catch-all became the s, so it transferred that ownership there. So we cannot use OPT down here, versus in the top example, we can still use OPT, because really the catch-all doesn't retain ownership of the value. I'm still wrapping my head around this, so feel free to correct me.
Does anyone know if you could put a reference sum and s?
Like a reference to s here, like here, yeah.
Yeah, do an and s there and like make it a borrow. That is a main block if you wanted to try it.
Yeah, that's a good point. You could copy that into Playground. Because I was wondering also, if you didn't use S on the right hand side, if you just use, even though you use it on the left hand side, does that move? That's another question I had.
I think even without using it, you're moving it.
There's the error.
Yeah.
Oh, so it actually recommends that.
Yeah.
Wait, what is the word? What does that mean? You put the word ref in there? What does that mean?
What?
It's suggesting adding this ref s.
I don't think I've ever seen the ref. I've seen and.
Yeah,
like ampersand.
Oh. Let's see. What ref s in print? Like some ref s here at the bottom. What's this? I didn't get.
Oh, it's a special. Yeah, it's a special. It wasn't in the chapter, but it's a special way to bind by reference. So you put ref there, it apparently will work. We learned something new.
Is that not the same as ampersand?
Let me try it.
I mean, I just learned about it just now, like you did.
Nope, mismatch types. It's because it expected a string and then it found ampersand everything else.
Expected string. Oh, because that's the type of the opt. Yeah. The solution the book's going to offer is to take the entire put the ampersand in front of opt, right?
Oh yeah, I think that's the solution.
But it's interesting. This ref syntax is something I don't think they mentioned in the book. I don't remember seeing it.
Yeah, exactly. This is the solution from the book. Yeah. So to make opt
I'll paste the doc
referenceable,
page
right?
for that.
I do like that ref part because it's just very intuitive there. So cool.
And on the bottom of that page I just posted, it does say what's the difference between the ampersand and the ref in the in that position.
Okay.
Very interesting. Yeah, the Rust compiler is pretty neat, huh? It teaches you sometimes.
It teaches, yeah. Yeah, I was doing some stuff this morning and it was exactly, I was like, this is so useful. And you just do that and it works, right? It's not a vague error that you have to read a lot, or I don't know.
Yeah, or
Someone
Python long stack trace.
Yeah.
Try working on a JVM language.
Oh yeah, right. I've seen those.
Scala output is just pages and pages of
for,
unrelated stuff.
for some small thing. Yeah.
So yeah, exactly. I guess in the next slide I had the book solution, which is just adding, up becomes ampersand opt, and then we can still work because opt is borrowed and ownership did not transfer. So match is one of the control flows that we can use, and then the other one is if let. This one's more concise, but it's not as exhaustive. So we can say, let match. We're gonna do some match print, etc., and then we catch everything. And I think I copied this from the book, but I don't remember. There was some kind of caveat about the use of this, because it said catch all, and then they had an example that said something here, and then now this one. So sorry about that.
I think
In
that's
the book,
because
I guess
the
it's
print line returns nothing, so the other option has to also return unit.
okay. So then, we use the if let, which just instead of writing this whole match and kind of opening here, we say if let some match. But here the difference is, right, we're not including the exhaustive scenario of catching everything else and what it should do. So it's a little bit less verbose, and you wouldn't notice if something is kind of slipping through the cracks there. The way I kind of thought of this is kind of like a scenario that you would use when you do like a inline if else statement, which is kind of short and maybe something that's not too risky or important. So yeah, just kind of define different types of possible variants, and pattern matching just allows us to destructure what's going on in the enums and match the specific patterns that we want. Option is just used to safely handle presence or absence instead of null. That is all. Yeah, I can go back if we want to kind of